In this lesson, I'm going to put the ratios together and look at proportions. I kind of gave away what a proportion is. It's nothing more than an equation stating that two ratios are equal. We already talked about ratios, comparison of two numbers. So now we're going to have two comparisons of two numbers. So I have my first ratio here on the left of A over B, my second ratio here of C over D. So now I just put some numbers in there that we can relate to. I can take a number like 3 over 5 and a number like 6 over 10. Those are two separate ratios, but they're actually equal. And there's a variety of ways to check this. Now, one way to do it is grab our calculators. If I type in 3 divided by 5, I get 0.6. If I type in 6 divided by 10, I get 0.6. We can see, yes, they're actually equal. That's one way to do it. Another way to do it would be, well, let's simplify them. If I simplify 3/5, there's really nothing to do. It's still 3/5. But if I take 6/10, I can simplify that. They're both divisible by 2. If I divide 6 by 2, I get 3. If I divide 10 by 2, it's 5. It's really easy to see that these two ratios are equal. Another way to look at it is by cross-multiplying. If it's really a proportion, when I cross-multiply, I'm going to get 30. I'm going to get rid of this. I'm going to end up with 30 when I go top left to bottom right. And if I cross-multiply going the other way, so let's go bottom left to top right, I get 30. And that's very easy to see that 30 equals 30, telling me that those two ratios are equal. So a variety of ways that you can check to see if two ratios are actually equal, making them a proportion. This is the one that I want you to really focus on. Because when I get here and I want to solve this proportion, I think one of the most effective ways, most efficient ways, is to use that cross-multiplying method, where I take and I cross-multiply. 6 times y, I can do that in my head and get 6y. It's going to equal, now I have to cross-multiply going the other way. Now I'm going to take the 9 times the 18.2, use my calculator, and I end up with 163.8. Now I have an equation that you've seen before that we can solve. Divide both sides by 6, and I find out that y equals 27.3. I have solved my proportion. So if you see solve a proportion, it's asking you to solve the equation. Find the value of the variable in the equation. My next example is another proportion, and I'm going to use the same technique I did last time. I'm going to cross multiply. I'm just going to start this way, and I'm going to take that negative 26 over 6, and I'm going to look at the negative being a part of the numerator. Now, if I wanted to, I could put the negative in the denominator. It doesn't matter. But 3 times 26 is going to put us at negative 78, and that's going to equal what I get when I cross-multiply this way. Now be careful on this one, because we have to take that 6 and multiply it by everything in the top left. 6 times the 4x is going to put us at 24x, and 6 times the 5 is going to put us at 30. Take our equation and solve it. I would add the 30 to both sides to start. Now I end up with negative 48 over here, equal to 24x. Divide both sides by 24, and I find out that my x value in this proportion is negative 2. I have solved my equation, or I have solved my proportion. Now my next one is going to work with a word problem. It talks about a boxcar on a train. Tells you it has a length of 40 feet and a width of 9 feet. Now we have a scale model that is made with a length of 16 inches, and we want to find the width of the scale model. Now what I know about this is the boxcar and its model are going to be proportional, meaning if I shrink one, I'm going to have to shrink the other one, or excuse me, if I shrink, say, one side length, maybe the length of the boxcar, I'm going to have to shrink the width as well, and I'm going to have to shrink it using the same amount. What I can do then is I can set up my proportion. So the first thing I do is I just kind of make the proportion, the two ratios, have them equal to each other with no numbers in there. Now I just have to figure out what what to put where. And I'm going to start with the width, because we want to find the width of the scale model. I don't know that. I'm going to just start right there with my variable. So W is going to represent the width of my scale model. Then what I need to do is I need to go in and I need to find the width of the actual boxcar. Notice it tells me the width of the boxcar is 9 feet. I'm going to put those two things together. Those would be the corresponding sides of the boxcar and its model. Now in my next ratio, I'm going to have to deal with the lengths. Being I started with the model in the numerator, I'm going to have to put the model in the numerator for the length. Come over here, it tells me that 16 inches is the length of the model. So I'm going to put my 16 in there, and then I'm going to need to find the length of the boxcar. Well, it tells me length is 40 feet. I can put that here. Now notice I'm not putting any of my labels in here, but I want you, what I could do is, I want you to think about this. This was in terms of inches, this was in terms of feet, told us this was feet. Well, now to keep these two ratios equal, you think about what has to go right here, and it's going to have to be inches, because in the second ratio I have inches over feet, so in the first ratio I'm going to have inches over feet. So when I'm all done, my width is going to be in terms of inches. Now I'm going to get rid of that stuff, the labels, so it doesn't confuse us when we try to solve our proportion. Now here we go. I'm going to cross multiply. So I'm going to go this way first this time. I'm going to get 40W equal to, go this way, cross multiply, and I end up with 144. And then I just need to finish solving my equation by dividing both sides by 40. And I find out that the width is 3.6. Now remember, my label was inches. So the width of my boxcar is going to be 3.6 inches. That's going to conclude my lesson dealing with the proportions.